ways in which it would have gotten there.
There is when we're going to begin to get answers to these questions that you're asking. And right now what we've got are hypotheses. And so the way that we can go about testing them is using the payload to make particular estimates of the environments that water may have been present in. And what I would say, the most important thing that we need to be left with is to make sure that in the year that we arrive at the Gale landing site, we can continue to refine our hypotheses and come up with particular observations that we would make. And I think the most important thing is the question of how much water may have been there. There may not be one answer. There could be multiple answers. The reason that Gale is attractive is because there's likely to be multiple scenarios in which water would have been present, but at this time we just don't know how much would have been there.
Space Magazine. I don't know if you can go back a couple of slides to that whole stratigraphy that you were showing, but have you started to map out how you actually climb the mountain? I mean, to the first order of, that's a 3-mile high mountain. I mean,
yeah.
And I realize the relief has been exaggerated there, but...
yeah, it's a 3 times vertical exaggeration, and we are committing only to climbing the lower part of the mountain. And in the project, one of the things that we did to confirm this site as being viable from an engineering perspective was we conducted a study by a subset of people on the team and within the project called the Gale Summit Team, and they were charged with the responsibility of making sure that we could actually drive there. So Mike and I got together with some of the engineers and a handful of scientists to try to drive this terrain, because now, don't forget, this high-rise camera is incredibly valuable because you can see this table from orbit. And so that means we could come up with accurate models in advance of arriving there and drive them across the terrain and make sure we can do it. So we had multiple paths that we found that we can get us up through those layers.
Okay. And if you were to get all the way to the summit, can you even guess at how long that would take? The full year?
No. I think basically where the blue star is, that would probably take us 2 years to get there. And then after that, as I said, you know, the warranty expires. But if history is a predictor of the future, we expect to have, you know, some future life left to go. But if we were to go on for 10 years, we think we could just keep climbing. It's going to take years to get to the top if it's possible.
One of the issues with how fast we go is how long we spend on the scientific investigations. So it's not just a matter of the engineering capability of driving. It's the fact that there's a sort of rich suite of things to look at. And so there's a balance between characterizing where you're at and going to see the next thing. And that'll be a very exciting part of the mission.
And one last one. Can you say how steep a slope this can climb and compare that to Spirit and Opportunity?
Mike, you
in some ways it's similar. You know, I think we probably will generally be climbing slopes around 20 degrees or so. And that's similar in slope capability in terms of traverse to Spirit and Opportunity. It has similar ground pressure, and so you probably expect it to be able to negotiate slopes that are similar to what we've seen for Columbia Hills or some of the crater entries.
Thanks.
Okay, we're going to take one more question, then we'll go to the phones and try to come back and wrap up. Okay.
Suzanne Presto from VOA. I had a similar question about time frame and how quickly will you be getting information back from this mission, and also given that Opportunity and Spirit have been going years beyond, do you really think that this could be going for 10 years and beyond that possibly?
You know, we'll see what happens. We have planned for a 2-year mission. The 2-year mission, we understand that we can achieve the principal science goals that we observe at and create hypotheses about there. And after that, we'll just have to see. But the point that Dawn was making is a good one. If we land and find something that's so incredibly interesting that we want to spend 6 months there, we probably will. So there's no requirement on this mission to drill a certain number of samples, analyze a number of rocks, drive a certain number of kilometers. We are really in the phase now where we are doing true scientific exploration, and we'll test hypotheses, and when we're satisfied, we'll move on. But that said, our hope is that our plan going into this is that we will move through some targets in the landing ellipse, and we do want to get to the base of that mound. That is our target for the mission.
Okay, let's go back to the phone. And Irene?
Hi, thanks very much. Can you hear me all right?
Yes, go ahead.
Hi, thanks. I had two questions. The first is if someone could maybe just talk a little bit about what the deciding factor was in giving Gale the edge over Eberswalde, which I believe was kind of tied for the top slot.
I'll take one crack at it. Essentially, it really was flavors of ice cream. It was very difficult. And so one of the things that we did was we had a meeting of the Mars Science Laboratory science team. So this is the principal investigators and all the co-investigators involved in the mission, and basically just did a vote. And we ended up with two front runners, Eberswalde crater and Gale crater. And then, but there's a slight preference for Gale. And as there was more discussion and also asking the PIs themselves, the 9 people who built the 10 instruments, there was a real preference for Gale in that it's not a one-trick pony. As we saw from this talks today, that there's several different environmental settings that can be explored, any one of which might have the possibility of preserving some organics. So you don't have to have the scientific hubris of thinking that you know exactly where to go or what mineral to target. You actually have the choice of several different things so that if one doesn't work, perhaps the other one gives you the great payoff.
Okay. Ladies and gentlemen, I'm going to have to jump in here. We are, unfortunately, out of time. This room has to be reconfigured for the Mars Day. But I would like to tell the media who are sitting here and the folks on the phone that these folks will be available. We will make them available following this press conference. And I want to thank you all for joining us. We want to thank the museum for hosting us. And when it comes to Mars, science never sleeps. Thank you.